Good morning, everybody. We are going to go through empirical formula calculations today. We have our 5 steps that we need to go ahead and fulfill to go ahead and figure out what that formula is going to be. So our first thing is going to determine the percent of each element. Some of the problems you will be given the percent. Some of the problems you need to determine what the percent is based off of the original masses given. All right. But we're going to start with some examples with the percent given, and then we'll get to those harder ones a little bit later in the unit. Convert your percent to grams in a 100-gram sample. Well, if you have a percentage out of 100, and then it is going to be a 100-gram sample, it's going to be the exact same thing. You're going to take that percentage and you're going to switch that to a grams value. If I have 70%, it is now going to be 70 grams. All right, that step is nice and easy. Step number 3, convert each mass to moles. We are going to set up that fence post. What are you given? What are you going to? What are you coming from? We're going to go from grams to moles. We're coming from grams, and remember, this comes from that periodic table, right? X is going to be from that periodic table, and then this is whatever you are given, and moles is always going to get that 1, okay? For step number 3. Step number 4, put it into a ratio and simplify. We always have to divide by that value to get that ratio. So in this case, we are going to divide by the smaller value, all right, and then write that formula based off of that ratio. So we're going to do a couple examples together, see what we got, and then we'll go ahead and go from there. All right, so here we go. First one. A certain compound is found to have the percent composition of 85.63% carbon and 14.37% hydrogen. Calculate the empirical formula. With this, all right, our first part of this, I already have the percentages, so I don't need to figure out the percent. Step number 2, take your percentages and switch it into grams. So I'm going to take that percent, 85.63% carbon, and now this is going to be 85.63 grams of carbon. 14.37% hydrogen, 14.37 grams of hydrogen. All right, step number 2. Step number 3, go from grams and convert each one to moles. So for this first one, I have grams of carbon. I'm going to set up my fence post here. I'm going to moles. I'm coming from grams. Moles always gets that 1. Grams, we're going to get that 12.01 off the periodic table. All right, and then we're going to calculate out what that is going to be. Okay. On the bottom, I have 14.37 grams of hydrogen. I want to go from grams of hydrogen to moles of hydrogen. So again, set up that fence post. Moles, grams, moles of hydrogen is going to get that 1. Grams of hydrogen off the periodic table is going to be 1.01. So for each of these, I'm then going to calculate, multiply across the top, divide by the bottom. All right, in this case, our 14.37 divided by 1.01 is going to come to 14.07 mole, up 7. All right, and then our 85.63 divided by 12.01, this is going to come to 7.04 moles. Okay, now with this, that is step number 3. Now we need to divide by the smallest for step number 4. So 7.04 and 14.07, each of these dividing by the smaller one. Smaller one is going to be 7.04. 7.04 to see what that ratio is going to be that we need for step number 4. All right, 7.04 divided by itself is just going to be 1. 14.07 divided by 7.04, this is going to come out to 2. In this case, our ratio is going to be a 1-to-2 ratio. Carbon to hydrogen ratio is going to be 1-to-2. So our formula is going to be CH2 as our empirical formula for this compound. Okay. All right, let's take a look at another example. Here we go. So we have empirical formula, find the empirical formula for a compound which contains 32.8% chromium and 67.2% chlorine. I already have the percentages like we talked about earlier. All right, let's go ahead and set this up. Percent to mass, I'm going to change that to 32.8 grams of Cr and 67.2 grams of Cl. All right, so percent to mass. Next, I need to go from mass to mole. All right, so I'm going to set this up. From grams of Cr, we are going to go to moles of Cr coming from grams. Moles is always going to get that 1. Grams is going to get that 52 as that round whole number off of the periodic table. Cl, we have this 1 mole on the top, grams on the bottom. Chlorine off the periodic table, 35.45. For me to go ahead and calculate the moles for each one of these. So I'm going to calculate this up. 32.8 divided by 52. I am going to get as my answer, let's go with some bright green here, 0.6307. All right, and my 67.2 divided by 35.45 is going to come to 1.8956. All right, now here we need to divide by the smallest. In this case, the 0.6307 is going to be the smallest and come out to 1. And then our 1.8956, this is going to be divided by 0.6307. This is going to come out to 3. So I have a 1 to 3 ratio. Cr to Cl is 1 to 3. So when I go ahead and write out my formula, this is going to be CrCl3 as our final answer. Okay, so writing out those empirical formulas, going through each one of those steps. Take our percent to mass, mass to mole, divide by that smallest, and take a look at that ratio. All right, I'll see you in the next video. Have a wonderful afternoon.